Artificial intelligence, AI, is a branch of computer science focused on creating machines or software capable of performing tasks that typically require human intelligence. These tasks range from basic functions like visual perception and speech recognition to more complex activities such as problem-solving, decision-making, and even creativity. AI can be broken down into multiple levels, approaches, and categories. Types of AI. 1. Narrow AI, weak AI. This is the most common form of AI today. Refers to systems that are designed and trained for a specific task. Narrow AI can outperform humans in a particular domain, but lacks the ability to generalize knowledge across different areas. Examples include virtual assistants. Siri, Alexa, and Google Assistant use natural language processing, NLP, and machine learning to respond to user queries. Recommendation engines. Netflix and Amazon recommend products or shows based on user data. Autonomous vehicles. Self-driving cars use AI to interpret sensor data and make real-time driving decisions. Spam filters. AI-based algorithms help filter unwanted emails by identifying patterns that suggest spam. 2. General AI, strong AI. General AI refers to systems that possess human-like cognitive abilities. A machine with general AI would be able to perform any intellectual task that a human can do, generalizing knowledge across domains. This includes common-sense reasoning, understanding emotions, creativity, and abstract thinking. General AI does not yet exist, but it is the long-term goal of many AI researchers. 3. Artificial superintelligence, ASI. This is a hypothetical concept in which AI surpasses human intelligence across all fields, including scientific reasoning, art, problem-solving, and social intelligence. ASI would not only perform tasks better than humans, but also develop its own goals, and perhaps even understand concepts beyond our comprehension. ASI raises ethical and existential concerns, particularly related to control, safety, and human relevance. Key AI concepts and technologies. 1. Machine learning, ML. Machine learning is a core aspect of AI where algorithms allow computers to learn from and make predictions or decisions based on data. Rather than being explicitly programmed, machine learning models find patterns in large data sets to learn how to improve their performance over time. ML can be divided into several types. Supervised learning? The model is trained on a labeled data set, meaning the data includes both inputs and the corresponding correct outputs. The model learns to predict the output for new inputs. Examples include image recognition, where the model learns to classify objects in pictures. Unsupervised learning. The model is given data without explicit instructions on what to do with it. It tries to identify hidden patterns or relationships within the data, such as clustering similar data points together. This is useful for applications like anomaly detection. Reinforcement learning. The model learns by interacting with its environment, receiving rewards or penalties based on the actions it takes. Over time, it learns to maximize rewards. This method is commonly used in AI systems for playing games or in robotics for controlling movement. 2. Deep learning. Deep learning is a subset of machine learning that uses neural networks with multiple layers, hence deep, to model complex patterns in data. Neural networks are designed to mimic the human brain's structure, consisting of interconnected nodes, neurons, that process information in layers. Deep learning has been particularly successful in tasks like image and video recognition. Systems can now recognize faces, objects, and even interpret actions in videos. Natural language processing, NLP. Deep learning models enable machines to understand, interpret, and generate human language. This is used in applications like machine translation, chatbots, and sentiment analysis. Speech recognition. Systems like Google Voice and Apple's Siri can convert spoken language into text with high accuracy. 3. Neural networks. Neural networks are the building blocks of deep learning. Inspired by the brain's structure, they consist of layers of nodes, where each node performs a simple operation, and collectively, they solve complex tasks. Key types include feed-forward neural networks. Information moves in one direction through the layers, from input to output. Convolutional neural networks, CNNs. Used mainly in image processing, CNNs detect patterns such as edges, textures, and shapes by learning from different filters applied across the image. Recurrent neural networks, RNNs, primarily used for sequence data like time series or language data. RNNs can remember previous inputs and use that memory to affect future inputs and outputs. This makes them useful for tasks like language translation or speech recognition. Natural language processing, NLP. Natural language processing enables machines to understand, interpret, and generate human languages. Key NLP tasks include text classification, sorting emails into categories like spam or not spam, machine translation, automatically translating one language into another, for example, Google Translate, sentiment analysis, determining the sentiment behind a block of text, often used to gauge public opinion on social media. Question answering asterisk, systems like chatbots or virtual assistants that answer user questions based on a knowledge base or real-time data. AI techniques and algorithms. 1. Decision trees. Decision trees are models that use a branching method to illustrate every possible outcome of a decision. Each node represents a feature, and branches represent decision rules. This technique is simple but effective for many applications, like customer segmentation and loan approval systems. 2. Support vector machines, an SVM. SVMs are supervised learning models used for classification and regression tasks. They work by finding the optimal boundary, called a hyperplane, that separates different classes in the data set. SVMs are used in tasks like image classification, handwriting recognition, and bioinformatics. 3. Genetic algorithms. Inspired by the process of natural selection, genetic algorithms search for solutions by simulating the process of evolution. They involve selection, crossover, recombination, and mutation to find the best solution over successive generations. These are often used in optimization problems, where many possible solutions need to be evaluated. Applications of AI. 1. Healthcare. AI is used for diagnosing diseases, predicting patient outcomes, personalized treatment plans, and drug discovery. AI models can analyze medical images, for example, X-rays, MRIs, detect patterns in genetic data, and predict outbreaks of diseases like flu or COVID-19. 2. Autonomous vehicles. AI enables self-driving cars to process vast amounts of data from sensors, cameras, radar, LiDAR, in real time to make driving decisions. These systems can recognize pedestrians, road signs, and other vehicles, allowing for safer and more efficient transportation. 3. Finance. In the financial sector, AI is used for fraud detection, algorithmic trading, credit risk assessment, and customer service automation. Chatbots. Machine learning algorithms analyze transaction patterns to detect anomalies that might indicate fraudulent activity. 4. Entertainment. AI is widely used in video game design, music composition, and content recommendation systems, for example, YouTube, Netflix. Machine learning models analyze user behavior to suggest content that users are likely to engage with. 5. Manufacturing and industry. AI-powered robots are used in manufacturing for tasks like assembly, quality control, and predictive maintenance, where machines predict when equipment will fail and schedule maintenance before a breakdown occurs. Ethical considerations in AIs. As AI continues to advance, several ethical issues need to be addressed. Bias in AI. AI models trained on biased data can perpetuate or even amplify existing inequalities. For example, facial recognition systems have been shown to perform worse on people of color. Privacy concerns. AI systems often require vast amounts of data, raising concerns about how that data is collected, stored, and used. Job displacement. As AI automates more tasks, there is growing concern about the impact on employment, particularly in industries like manufacturing, retail, and transportation. Autonomous weapons. There is a growing debate about the use of AI in warfare, particularly around autonomous systems capable of making life-or-death decisions without human intervention. Conclusion. Artificial intelligence represents a transformative set of technologies that are reshaping industries, economies, and society at large. While AI can greatly enhance efficiency, innovation, and decision-making, it also raises important ethical, social, and economic questions that must be carefully considered. AI continues to evolve, with breakthroughs in deep learning, reinforcement learning, and natural language processing pushing the boundaries of what machines can achieve. The future of AI holds both immense promise and significant challenges.